Good morning, everyone. Probably have a few more people straggle in here, but I'll go ahead and introduce myself. My name is Lyle Mullican, and I'm a consultant based in the mountains of Asheville, North Carolina. I've been using Rails for a long time, since version 1. And a lot of my work is in the healthcare sector, where we try to take security very seriously. So we're going to talk a little bit about application security this morning. So it's been an observation of mine over the course of my career that development teams have a lot of tools for specifying the features that we expect our software to have. We have user stories, we've got wireframes, we have mockups, but we don't have nearly as many tools for expressing the security characteristics that we expect our software to exhibit. And there are companies that have those tools, that do a great job of this, that have a very strong security culture, and if you work for one of those, that's great. But I think that for a lot of developers, and especially in smaller teams and startups that are trying to get off the ground, we're very focused on making the software work, make it do what it's supposed to. And so we have very well-defined expectations for user-facing behavior and just sort of a vague expectation that along the way it's going to be written in a secure manner, but without a lot of definition for what that actually means. And occasionally you might end up having conversations like this, particularly after there's been some well-publicized security story in the news where a boss or maybe a client, a product owner, asks questions about the security posture of an application by saying something along the lines of, is this application secure? Or maybe if they're slightly more sophisticated, they might ask, how secure is the application? But there's an assumption built into this kind of questioning that security is something that we can actually achieve, that it's either a box that we can check, or maybe that there's a spectrum with insecure on one end and secure on the other end, and we know we're somewhere in between, but we're trying to move ourselves toward that secure end of the spectrum. But if you kind of stop and think about the security features that we actually build, the kinds of security controls we try to implement, it doesn't take you very long to realize that that's actually not how security works at all. So what are we talking about when we use this word, particularly when we use the word to describe software? We're really talking about risk and how we manage risk, the controls that we put in place to try to limit the risks that our software faces. So security ends up becoming this kind of verbal shorthand that says we believe that we've accurately assessed the risks that our software faces, that we've applied controls, usually technical controls, to bring those risks to an acceptable level for our business. And that phrase, the acceptable level, is very important and something we're going to come back to a little bit more later on. But any security control is generally designed to address a very specific scenario, and usually at a point in time. So often in security conversations, people like to use metaphors. So if you imagine living in a castle, towers and big stone walls, you ask yourself the question, am I secure? Well, it all depends what your threat is. If your threat is a medieval land-based army, you're reasonably secure against that threat. If your threat is a modern army with modern technology, you're probably not particularly secure at all. Maybe for a more technical example, you think about HTTPS. Well, it's got S right there in the acronym. The S stands for secure, right? So to the general public, they access a website and they see that S in the URL bar and a little padlock and all of these things that tell them that is a secure website. But as technologists, we know that it's not the website that's secure at all. HTTPS tells me nothing about what the website is doing with my information. It's the connection to the site that's secure, and even then, it's only secure against very specific scenarios that HTTPS was designed to address. So any definition of security can really only be based on a definition of a threat. And so I think instead of asking whether something is secure, what we should be asking is in what ways is it secure or not secure. And I like to break that down further into a few more basic questions. And these are questions that we should be asking ourselves all the time as we build software. We can ask them at different levels too, different contexts. We can ask them at the level of code, when I introduce a new method, when I change the behavior of a method, when I'm working on a feature, or I can ask them about the system as a whole, the software application in general. So the first question, and really the first two kind of go together, ends up becoming a definition of what in the industry we call a threat model, which is basically what are the things we're worried about? What could go wrong in a security relevant way? What could cause harm to the software, to the business, to its users? And how likely are those things we're worried about to actually happen? Once we understand that, then we can ask ourselves, well, what do we do about it? How do we stop those things from going wrong? And what happens if things still go wrong despite our best efforts? So we can recognize that we're always going to be making trade-offs. I think that the hardest question for developers is often not what the threats are, but how do we prioritize them? How do we figure out what deserves the most of our limited attention? And what ends up being the acceptable level of risk for a business? The most secure design that we can come up with is probably completely impractical. So if I'm worried about SQL injection, and I am, then I could design a system where my application isn't allowed to talk to my database. I could say my application is going to print out questions on a piece of paper that a DBA is going to pick up, interpret, walk over to an air-gapped machine, and type in his own query. There's very solid protection against SQL injection. It's also completely impractical. So as a business, we have to recognize that we're going to land somewhere between that and a database that's publicly accessible to the internet. There are trade-offs we have to make. So there are a lot of security features I could have. How do I think about which ones I really need and which ones I really need to be working on right now? So I'm going to talk about one way of thinking about that. It's certainly not the only way. And there are lots of ways of developing a threat model in general. Some of them are very formal, and we don't have time to explore all of those. But when we talk about prioritization, how do we think about which threats we need to be focused on the most right now? Here's one way of having that conversation. Something you can do on a whiteboard with a team and just start a conversation. I like to think of these things along two axes. We have a line that says whether something is more likely or less likely to happen, to be a problem for us, and then the other axis says whether something is more or less likely to be damaging, or how much damage is likely to be caused to the software, to the business, to its users, if that threat occurs, if the attack is successful. And this is both very subjective. It gives us a starting point. There are no units of measure. I can't say, and nobody can really say, that there's a 90% probability that this type of attack is going to occur. There's a 10% probability that another type of attack is going to occur. But I can say, based on what I know about the state of the industry, about the kinds of traffic I see in my application logs, about the type of business that I'm in, that this is a more likely scenario than this other scenario. And I can start to compare things against each other. The point is to set priorities and to figure out of the vast landscape of everything I could be worried about, what's most important. You know, these specific examples aren't important, but it's important to recognize that some threats are very common because they're easily automated. Others are less likely to happen because they require targeting, but unlikely scenarios are also sometimes still things we really need to worry about because they can potentially be very damaging. So generally, if we start thinking about things, comparing them in this way, we can set priorities moving from the upper right quadrant down to the lower left quadrant. The things that are both very likely to be a problem and very likely to cause great harm are the things that we need to spend most of our attention on. So once we have that conversation, once we have a starting point, this is still something that we should revisit continually. So no threat model in whatever form it takes is ever complete. Just in the same way that you spike a feature, make a prototype, get feedback, and start iterating on it, you want to do the same thing when you're thinking about security threats. So once we have something written down, though, in whatever form that takes, we can then start to ask ourselves further questions. We can say, what do we do about these things? What controls do we already have in place? What are gaps that we have where we feel that we're not adequately addressing this problem? And then we can prioritize the work to close those gaps. Now, the good news at this level is that designing security controls is usually not that hard, because most of the time, everybody else has the same problems I do, and smarter people than me have thought about the ways that are effective to address the security concerns that I have. There are probably well-established approaches to controlling them. We know the kinds of things that we need to do to prevent SQL injection. We know the kinds of things we need to do to prevent cross-site request forgery. But what is hard is actually doing it. So one of the big questions that we need to ask ourselves, both for controls that we already have and for things that we're thinking about implementing in the future, is how do we know that they're actually effective? How do we know that the security controls we have are actually working and functional? And the answer to that is the same way that we know the behavior of our software is correct in any other way. We test it. Now, in my own progression as a developer, I was fairly slow to adopt test-driven development and really automated testing in general. Before I started working with Rails, I was a PHP developer, and I wrote PHP in the traditional way of typing stuff in a text editor, then opening up a web browser and pushing the refresh button to see if it did what I wanted. Eventually, I realized that doesn't scale very well, and I understood the power of automated testing. And once I started writing really good tests, what I found, something that probably most of you could have told me if I'd bothered to ask, is that learning to test made me write better code in a lot of ways, because I started thinking about how I'm going to test the code that I write. It made me think much more critically about the way that I was writing it. And security testing will do the same thing. So when you start thinking about how we're going to test the security controls that we implement, we design better security controls. So security testing should be a very important part of your test suite, part of your CI pipeline, whatever you have. If you're not testing your security controls, somebody probably is. And you really don't want to be outsourcing security testing to the internet. But there are several different kinds of security tests that we can look at. So we're going to walk through a few categories, ways of approaching security testing. So the first one of those is simply explicit tests for controls that are built into our application. And this is just like any other test of an application's behavior. This is an example in Cucumber. But direct object references are a big problem for a lot of web applications. So in this example, we have an access control to ensure that a user can only look at their own orders. And in the test, I'm validating that not only is that true, I'm denied access when I try to get at somebody else's stuff, but also then what the response to that is, what happens if I try to. And that's also something we're going to talk about just a little bit later on. Explicit tests will only cover, of course, exactly what I tell them to cover. So they'll tell me if the security controls that I've designed are doing what they're supposed to, if they're behaving as expected. They'll alert me if a change is introduced that breaks that behavior. What they won't do is help me find things that I am not already thinking about. And so for that, I need other types of tests. So the next category of security testing is static analysis, and there are different tools that do this. This output is from Brakeman, which is a tool that many of you may already be using. It's Rails specific and very helpful. It's highlighting here for me a possible SQL injection vulnerability where I'm passing user-controlled input into an active record class method that does not sanitize that value. So what static analysis is good at is that kind of thing. Static analysis tools can trace the handling of input through many levels of indirection in a way that's hard for a human being to do. They are not executing the application code at all. They're analyzing what it does, and it is possible to have false positives when you do this kind of analysis. So sometimes developers get frustrated, I think, with the output of tools like this. But to me, a false positive from a static analysis tool like Brakeman is a code smell. Because if I've made my code hard for Brakeman to understand and reason about, then I'm probably making it too hard for people to understand as well. And that may not always be the case, but often I found that it is. Another type of tooling that I would lump into the static analysis category as well is the auditing of dependencies. So most applications are not just using their own code, but pulling in gems and other dependencies that may have their own problems that come along with them. So another important piece of a comprehensive approach to automated security testing is auditing the state of the gems that you depend on. And there are some different tools that do that. One that I use is called Bundler Audit, which pulls in an open source Ruby advisory database and simply checks the contents of my gem file every time I run my suite to tell me if there's anything that's missing an important patch or version upgrade. So the next category of security testing is dynamic analysis. So where static analysis tools don't execute the code at all, but only understand its structure and the way that it's handling data, dynamic analysis tools are doing the opposite. So they're running the code, they don't know anything about its internals and how it works, but analyze the output. And for some people, especially in the business world, dynamic analysis is really what they think of as security testing. So people will call this a vulnerability scan, that sort of thing. I'm not sure that's the best label for it, but it can only see the results of execution. So what dynamic analysis is good at is generating a whole lot of unexpected input and seeing what happens, how the application reacts to that. It's good for finding problems in string handling that may not even be security vulnerabilities, but if you start to see your application throwing a lot of errors because of the kinds of input that's being generated by one of these tools, then that can alert you to problems in the way strings are being handled in the code, even if there's not an obvious vulnerability attached to them. It's important a lot of times with this kind of tooling to give it access to an authenticated user, because I found that a lot of applications may be fairly well locked down to the public, but once somebody logs in, there's an implicit level of trust associated with them that is not necessarily deserved. And so giving a tool like this access to a user account and letting it probe the application and see what it can find is often very helpful. And the other good thing about this approach to testing is that it's going to exercise the full stack. So it's running requests through the server, through rack, through all of the gems that are involved in servicing a request. And so that can be helpful in finding problems that may not be obvious when you're just looking at a pull request sort of in isolation. This kind of comprehensive test is helpful there. The fourth category is manual testing, and where all of these other approaches to security testing can be done pretty quickly, easily, cheaply, for free even. Manual testing is expensive. It has a cost both in time, money, expertise. But a human being can do things that none of these automated tools can do. So a human being can get a feel for an application. If it's someone who has substantial development experience, sometimes by looking at an app's behavior, they can start to get a sense of how it works, the kinds of things that might be going on inside it, and they can start to make guesses and inferences about it, start pulling on suspicious threads and seeing where it takes them. Sometimes a person doing manual testing will start with automated tools to find suspicious things that look like they might be a vulnerability, and then start probing further to find out if they can really be successfully exploited or not. So manual testing, particularly if you're dealing in any kind of sensitive data, I think is still very important. And there are a lot of ways that you can go about it. You can have dedicated staff if your organization is big enough to do that. You can have a bug bounty program. You can hire consultants to do penetration testing, but it is an important component to a comprehensive approach. And somebody who's manually doing testing is going to be doing essentially what a black hat would do in a targeted attack. Defense in depth is a phrase that's used a lot in security conversations, and it applies to testing. So none of these approaches are mutually exclusive. You can pick the ones that work best for you. You can layer them together, and probably should. The idea with defense in depth is that when we layer security controls on top of each other, it gives us more opportunities to be wrong. And I like having as many opportunities to be wrong as possible. So if one control fails, another control is going to stop the attack. So again, take the example of SQL injection. So maybe I have a web application firewall sitting way out here in front of my application, analyzing traffic for malicious patterns, but something gets through, and that fails. So then in my application code, I'm doing a good job of sanitizing my inputs, so even if that query makes it through the web application firewall, my code is gonna make it not useful. But maybe I missed something. And so there is a SQL injection vulnerability in my app. But the application has a database user with the least privilege required. And so even though the SQL injection is successful, it can't actually do anything useful. And so that final control is the thing that saves me. That's what defense in depth means. We layer controls together. And when we talk about it in testing, none of these approaches to security testing are perfect, and they're all going to miss some things. But when we layer them together, it increases the confidence that we're finding as much as we can. So now I want to tackle what happens when there is an attack going on, and particularly if the application maybe still has problems that we haven't found yet. Incident response is a very broad topic, not something that we can explore too much this morning, but I do want to talk about one very important aspect of it, and that is this. Usually, an exploit takes time. It takes time for an attacker, whether it's an automated script or somebody manually probing to find things, it takes them time to find the vulnerability and to figure out how to exploit it successfully. So most security conversations, particularly in business, focus on preventing attacks. How do we lock this application down? How do we make sure that nobody can do something malicious with it? And that's important. But we've probably all got problems that we haven't found yet. So if that's the case, detecting an attack when somebody is probing, when somebody is trying to find that vulnerability, detecting it quickly and doing something about it can be just as critical. So I'm going to look at a couple of very simple ways to do that. There are much more sophisticated ways to do it. You can buy big, expensive security appliances and deploy them in your infrastructure. But if you're working in a small app, there are very simple things you can do just in application code that can make a big difference. So here, I'm going to implement a non-existent route in my application that has a very predictable name. So this is the kind of thing that somebody who wants to probe my application for vulnerabilities is likely to try to poke at and see if there's something there. So does this application have an admin tool that I can try to get into. So before I made any changes here, if you hit that admin path, you would get a 404 because it doesn't exist, and then you'd move on and try to do something else. That's still what happens in this case. I've connected this route to a controller that I called Tripwire, and you still just get a 404, so from the outside it doesn't look like anything is there, but I'm doing one thing, which is that if it was an authenticated user who was trying to hit that URL, I'm just going to send some kind of a notification, whatever that looks like, for my team, because that indicates to me that somebody is up to something. They're doing something that they probably shouldn't be doing. Another example, this one is maybe more hands-off. So one of the first things that an attacker probably wants to do, if they're probing my application, is they figure out what app stack I'm running. It may not be immediately obvious, so they're going to try some things to see if they can tell. A lot of people run WordPress, of course, so I'm going to connect here a WordPress path to my Tripwire controller. And now, instead of sending an alert, I'm just going to ban the IP address if somebody hits that route. So it's a Tripwire that shuts the door. And there are lots of ways to do this too. It is not necessarily the most efficient thing to block IP addresses in application code. But again, if you have a small app, it can be effective. At scale, you need a way more sophisticated infrastructure to handle this kind of thing. But even in small apps, simple measures can sometimes make a big difference in your security posture. Managing IP blacklists by hand is not going to work very well. If you can automate something and make it hands-off, then you're reducing your attack surface. So here, I stick the IP address that hit this route in a cache entry. I give it an automatic expiration so it doesn't grow forever. And then I can use the rack attack gem to read that cache entry and deny access to the IP address for the time that it lives. So very simple, very easy and free to implement, and it reduces the attack surface of my application. But however you approach these kinds of things, for any type of incident response, I think the biggest key is to limit the number of decisions that you need to make under pressure. So how do we block a bad actor? Is that something that lives in the application? Is it something that lives farther upstream? These are not questions we want to be asking ourselves when we're trying to respond to an incident. These are things we want to have thought about beforehand. What are the criteria that we would use to make those decisions? And when you start planning, thinking about scenarios, thinking about what could go wrong, again, asking that first question, what are the things we're worried about? What could go wrong? You may not encounter the actual scenarios you planned for. You may end up in a very different place than what you expected, but the act of planning starts to give you tools that prepare you to adapt to what actually does happen in the real world. So speaking of being prepared and responding, I said at the beginning that you have to recognize you can never control all risks. There is always some level of risk that anybody who's running software connected to the internet is going to face. So of course we want to prevent as many security incidents as we can. But just as important as preventing them is how well we react to the things that do happen. And resilience is one way of thinking about that. So this is a term that can apply to software. It's a term that can apply to individual people, and it's a term that can apply to organizations, groups of people. So how is my software designed to handle failure? In security terms, it could mean limiting what data I store in the first place. That could mean how I segment networks and applications from each other, how I layer controls together, so that when something fails, the damage is limited. On the human side of things, resilience asks, how do I, as an individual, handle failure? When I write code that turns out to be vulnerable, how do I deal with that? How do I respond to the failures of other people when I find the code that they've introduced? Do we try to hide those problems, hope they don't happen again? Do we look for someone to blame, especially if there was an actual event that occurred as the result of a vulnerability? If we try to learn from the things that happen, how do we learn? How do we capture that knowledge and share it with others? I'm sure you're familiar with imposter syndrome. It's already been talked about here at the conference several times. And it's something that there's a lot of important conversation happening about, I think, in the community as a whole. It's this sense that a lot of developers live with, that everybody else knows more than I do. I'm afraid of being found out. I'm afraid that people will realize I don't know enough, that I should know, because security is so important. I think this feeling is especially sharp for people in the context of security, because security failures often come with this layer of moral judgment attached to them that maybe other kinds of bugs don't necessarily get. Which is reasonable to a point, because we do need to recognize that real harm can be done to real people when security isn't taken seriously. But we also need to remember, and we need to encourage other people in our organizations to remember, that security is hard, and it's hard for one very simple reason, which is that defenders have to be right all the time, and attackers only have to get right once. So when we have conversations about security topics, we need to be careful to reframe them and not let this assumption creep in to the words that we use or that we hear other people using, that any system can be perfect. There really is no such thing as a secure application. But we do need to be having conversations about security topics with people who may have naive ideas about how security works in business. So all of these tools that we've talked about can help us in reframing those conversations. When somebody starts going down that pathway of saying, it should be this way, you should have known this. As long as we have these things written down and hopefully agreed to, and preferably involving non-technical people in these conversations. So if we're trying to develop a threat model, we're essentially asking ourselves, what are we worried about? Well, as technologists, we've got a long list of things that we're worried about. Business people may have a slightly different list of things that they're worried about. And it's important to involve them in those conversations. If we have expectations that are clear about how we approach security in our coding practices, and we write them down, that becomes a conversational tool. If we have security testing as a part of our automated test suite, and that output is available for everyone to see, that's a conversational tool. And when we do planning exercises and think about how will we respond to an event, and when an event does happen, we talk about what happened and how we dealt with it. Those are conversational tools. And all of this gives us structure as we try to develop a culture of security in an organization. So when there's structure, it changes the nature of security conversations. Without it, if there's a failure of security, whether it's a real failure, an event that occurs, or it's a theoretical failure because a vulnerability is uncovered, without structure around our security expectations, what we're going to tend to do is look for someone to blame. Say, well, who introduced that code? And why didn't they know better than to introduce that code? We're going to look for somebody to blame, and we're probably going to shame them. But when there's structure, and we have a documented, written down approach to security, then it changes the conversation into blaming the system instead of a person. And when we blame a system, then we can look for ways to improve it. We can say, well, our threat model was incomplete, our tests were incomplete, and we can do something about that. A few tools and things that I've mentioned along the way here. Brakeman, again, is a static analysis tool that's very helpful. gems that I referred to in the examples, bundler audit and rack attack, and some resources to explore some of these ideas further. For Rails applications, there is a security guide among all of the other excellent Rails guides. OWASP is the Open Web Application Security Project, and they publish a guide to secure coding practices, which is definitely worth a read. Every year they publish a top 10 list of the things that we're all still doing wrong as an industry, which is also worth reading. The US Computer Emergency Response Team tracks vulnerabilities and publishes feeds of them, and that's also worthwhile to get a sense of the kinds of things that are going on in the industry. Thank you very much, and find me at the conference if you have any questions or want to talk about security.